Okay, so we're going to look at overriding .java. Now, what overriding means, basically, so okay, so we are going to look at overriding in Java, which is method overriding. Now, what method overriding means in object-oriented programming, it allows a subclass to provide a specific implementation of a method that is already defined in its superclass. Now, what we normally talked about overriding in the fundamental concepts in Java and other object-oriented programming languages, basically, we're trying to look at how this OOP allows a subclass to provide a specific implementation of a method that is already defined in its superclass. So method overriding is a way of achieving a runtime polymorphism in Java. Now, where we will look at the method, and then later we will try to call an object to determine its object runtime based on the actual object type. Now, to override the method of the subclass must be the same as the name and then the return type and the parameter as the method in the superclass. So those are the few key concepts that you need to master when understanding this concept, method overriding. But it's quite similar to method overloading. So I'm going to create a multi-line comment. Now in this multi-line comment, I just want to explain method overriding for you to get it well on your end. Method overriding is a fundamental concepts in Java that in Java and other OOP languages that allow a subscriber that allows a subclass to provide a specific implementation of a method that can be of a method that is already defined in its superclass. Now, I say that the method subclass must have the same name, return type, and parameters. and parameter list as the method super class. Now, basically, this is what you need to focus on when understanding the key concepts of method overriding in object-oriented programming. Basically, it allows a subclass to provide a specific implementation of a method that is already defined by its superclass. Now, there's few rules that you really need to understand when dealing with method overriding. So, rules for method overriding. So rule number one, in summary, is that the subclass must have the same method signature. That means going to be name, return type, and parameter list. This is parameter list. Please mark those rules very well. I can easily examine you on that one. Then another one is the access modifier of the overriding method can not be more restrictive than the access modifier of the overridden method. What it means, in other words, is that if a method in the superclass is declared public, the overriding method in the subclass can be public, protected, but cannot be private. So I'm just meaning method overriding okay, it works. Let's say if the method in the subclass, if the method in the superclass is declared as public, okay? Please note this word, is declared as public. If it is declared as public, try to note it on your end there, okay? The overridden, the overriding, let me just write it on a new line there. Overriding method in the subclass can be public or protected, but not private. Please take note of rule number 2. Then the last rule, which is rule 3, is that the overriding method cannot throw a border exception than the overridden method. So, which means it throws the same exception, a subclass of the exception or no exception. So, in other words, not declare any exception with throws. So, not declare any exceptions with throws. Now let's look at this in a live example. We're going to look at a simple example. First, I'm just going to explain this example concept and then you follow it. Now, this is going to be our example one. Let's look at only two examples today, since we are completing model. Let's see. Example. Let's look at example two. No, example one. We remember we dealt with the animal classes, where we were able to look at the class of animal and then the method of the sound they make, where we look at the sound the dog makes and the sound the cat makes. So that's what we're going to try to look at it. So in other words, here what we're going to focus on is that method overriding. We will look at it in a more specific way, how the behavior of maintaining common interfaces defined in the superclass can be achieved using a polymorphism. So let's try to write this using a script, and we look at this example of method overriding, how it can be executed. The code is going to be simple. Now, what I have to tell you is that always first create the class. We're looking at animal. Class, animal. You forgive me about my background because I'm normally today I'm in a noisy place. So class animal void, then we can say make sound. Now we shall say system out the animal makes a sound. Okay. Then we shall have class dog extends animal. Then we shall say method overriding. Then we can here say void make sound. Then we can say system out the dog barks. Okay. Now we're going to look at the output. Now in the output here, we'll have a public class where we say public class. This time around, the public class is what? overriding, then public void public static void string okay. So what we're going to say here is that we're going to use kind of a polymorphic assignment where we shall say animal new dog. Then what are we going to say? Polymorphic assignment. Then we shall say animal make sound. We don't actually have error with this source code, but the 37 errors are coming from the previous codes which were written in Java that are not being executed. But if you get an error, we will try to see how we can maybe save this file in another directory which has only a single Java file. So let's do that make sound. Then we call the make sound. We call the make sound method of dog. Is that okay? So always try to save so that you could pretty formatter helps to format your source code. So basically, in this example, I'm just going to explain the source code once again, is that we're looking at the class animal with the method. The method is what? Make sound. Then you're trying to output the animal, make sound. Then we're also looking at overriding the dog class with make sound. So this class dog, the dog class is invoked, which is demonstrating this class here, void make sound. It is invoked, which is demonstrating method overriding. So this class dog, it is invoked. Class dog is invoked, demonstrating method overriding. As simple as that. So let's run the source code and see. So literally, what method overriding does is that when the class dog is invoked, it definitely demonstrates what we call method overriding. Innocent, you want to close? These guys, I'm going to end them at around 9. Yeah, I'm actually lecturing. It ends at 9. Okay. Okay, so let's proceed. Let's proceed with that. So basically, it explained that exceptions from this method. So this is exactly how you demonstrate method overriding. Now we're going to look at one last concept in methods, which is called recursion. Let's complete this module 3 today. The rest, module 4, 5, 6, I think we will complete it when I'm in Cameroon. recursion. Now let's look at recursion in this way. Basically in programming, we have a technique which calls itself to solve a problem, and that is using the break, maybe a function break a problem into smaller sub-problems and solve the sub-problems and combine their results to solve the original problem. So in simple terms, recursion is widely used in various algorithms and especially well situated for solving problems that have recursive mathematical structure. There are four. There are four recursion functions that we need to look at it when dealing with recursion. One of them is, let's say we are dealing with a factorial of a number, and then maybe you want to look at its factorial. You can demonstrate this using recursion. You need to have some small mathematical understanding of pure maths to understand the small key concept. So let's first explain recursion here. I'm going to use multi-line comment. So recursion is a programming technique in which a function calls itself to solve a problem. Solve a problem now. So what recursion means is that recursive functions breaks a problem into smaller sub problems. So it is solve the sub problems and combine their results into and combine their results to solve the original problem. Now, recursion is widely used in various algorithms and is especially well situated for solving problems that have a recursive mathematical structure. Now, here the thing. Here the key characteristics of recursive functions in programming. Now, I'm just going to list them and explain them, but you could expand on your knowledge when you get the notes. One of them is what we call the base case, where you could try to note down this. The base case is literally a recursive function that have one or more base cases that specifies when the recursion should stop. These are situations where the functions returns results without making any further recursive calls. Then another one is called what we call it what? Recursive case, which basically means recursive case looks at the function call itself with the modified argument to solve a smaller or simpler sub-problems. The goal is to reduce the problem towards the best classes. Then there's what we call the function parameters, which basically is a recursive function that often take parameter that represent the problem to be solved. The parameter are typically modified for each recursive call to approach the best class. Then the other last key characteristics of recursive function is called the function return. Maybe for the purposes of you taking notes about this, let me expound on these explanations so that you could easily have this in your mind. Then we look at example 2, and then we see if we can have this lecture done. I'm going to check in the chat if there's any communication that regards this, but sir, I beg your pardon on demonstration of overriding. I didn't see how the program runs. Oh, sorry. Sorry about that. But basically, with the explanation of this is that when I run this script and then I continue, it's basically try to explain. There's a thread in the void make sound. Maybe literally my code doesn't have a problem, but when you look at here, there's a bank, there's a person. All these are coming from the previous source codes that are within that same directory. So it makes it very difficult for me to, it's trying to pull even errors from the other directories. So in a simple words, what I can say is that please, when you're running this source code, run it on a folder that does not have any Java file. But I'll share with you the code in the GitHub. Then maybe if you need probably, if you get maybe an issue or challenge, we'll try to have that. But literally it has no problem with that. Maybe I could try to, I don't know if I could try to create it in another folder, because I've already finished explaining this. But let me just create it in another folder and demonstrate. Because that folder has files which are in Java, and they're literally not making that script to be executed normally. So I'm trying to create a folder. And very soon my environment is going to be more quiet. Because I'm sure these guys are about to leave also. Okay. I don't know. Okay, let me just call Edwin.java. And I reproduce the source code here. Then public main. Okay. So what's the name of that gentleman who commented in the chat? We need some guidance on how to use it on the GitHub. So I didn't see how the code runs. That was Lule. So Lule, I'm now trying to, let me actually turn this up, then clear. So Lule, when I run this code here, it executes normally, the dog barks. So this is what I was trying to demonstrate. But remember, in the previous source code where we had so many files of Java, my source code was not able to run because it was trying to look at all those other problems. That's why it was not running. But as you can see here, when I clear this, and then I run, the code actually works. The dog barks. Animal make sound. What did we say about make sound? Make sound. So this class here is a superclass which is being written by the subclass of this. So that's how it works. I hope I've answered you, that gentleman. So even the next example that we are going to look at, I wanted to expound more on recursion. I wanted just to explain those key concepts of recursion, which here are the key concepts. Key concepts of recursive function in programming. So the first one is called base case. So the first one is called the base case, which basically means every recursive. But are you able to see my screen? You type yes if you are able to see my screen.
Yes, we can.
Okay. And you know, with these online classes, and I'm trying to compete with the noise in my background. But now I'm explaining these concepts. Did we try to do a mock-up quiz test? Because I think I have like 2 groups which I have not done. I'll try to make sure I be more productive tomorrow. So the best case is that every recursive function must have one or more just a second, must have one or more base cases that specify when the recursion should stop. Now that is one. Then the second one is called the recursive case. Recursive case, which basically means that the function calls itself with modified arguments. To solve a smaller or simpler sub problems. Then the other one, which is called the function parameter, basically the function which is recursive function often take parameter that represent the problem to be solved. Okay. Then the goal is to reduce the problem towards the best cases. Now we also have another one which is called what? Function return. Now, recursive functions return a result in each recursive call. That means the function may return a value that is part of the solution. Of the problem or to the problem. Yes, so those are the four things that I really wanted to explain them. So let's look at a simple example of a recursive problem, and we conclude our module. We conclude our module 3. So let's look at example 1. We can have more examples when we are done with the entire course outline. So we will have the public. Guys, it's not appropriate to write the code here, since I'm going to share with you the source code. We are likely going to have errors. Is that okay? Remember those errors. So let's create a new file and we call it what? Recursion.java. Is that okay? So from here, we'll come to it later. Let's first push it down. Now we can say we want to look at a factorial. The method that calculates the factorial of a non-negative integer n. Now, the best case is when n is 0, and that the case that returns that the result is 1. And in the recursive case, the method calls itself n minus 1. The factorial is n minus 1, okay? So we'll try to look at that and multiplies the result by n. So let's say that when the factorial method is called, the number will be like 5. Like n number equals to n is number equals to 5. And it makes a recursive call as follows. Factorial of 5 calls factorial 4. Factorial of 4 calls factorial 3. Factorial 3 calls factorial of 2. Factorial of 2 calls factorial 1. Factorial 1 calls factorial of 2. So this is how we are going to demonstrate that the base is rich, and that is where the recursion must stop. So this is how we're going to demonstrate the use of the factorial. Let's try to look at this using a simple JavaScript. So we're going to have a public class recursive. Let's call it recursive factorial. Public class recursive factorial. Now we are going to say the public static int for integer factorial. Then we can say int n. Now you can have what they call the base case. So the factorial of 0 is 1. So the factorial of 0 is 1. Now we're going to use a logical statement if n is equals to 0, then we will not say what to return, but basically we can have something like this. It should return 1, okay? Then from here, we can say a recursive case of n factorial equals to n raised to power n minus 1. So else, which is the otherwise, else return n factorial n minus 1. Okay. I hope everything is okay. Let's hope everything is super okay. There's one problem here. What's the problem? The public type recursion must be defined in its own file. Okay. Okay, so let's try to make sure that everything is super well. Which is the factorial, and then that, then okay. Let's see if we get an error, we'll have it solved. So now what you're going to do is that okay, I think I got all where we are coming from. Let's first remove this, and we call this to be recursion. So we can now do a public static void main. Then you can have an int of number then you can say int of result equals to factorial of a number. Then you can say system out. Then we can say factorial I think there's something missing here. This statement is not complete. So factorial of plus factorial, we didn't call it result. Just call it factorial of number plus is, which is a string, so let's see if it can run and give us the factorials. Wow, So the n recursion is the factorial of n. 5 is 120. So this is exactly how you demonstrate the use of factorial. And these guys have also, you are now leaving, eh? You made me to struggle with noise. Now this class here is going to have some noise in the background for those who have missed. Anyway, I think that is it with module 3. If you have any question, maybe I should attend to it. Next week I'll be in Zimbabwe. No, I'll be in Cameroon. So I'll be leaving Uganda on Saturday, I think at around this time. So we will have online lectures for the next 2 weeks. I'll be back in Uganda on 5th. Then I try to complete the remaining modules. Yeah, then I set you ready for your end of final SEM exam. But we will do kind of online test. Maybe if I come, we can try to do in-person test where you sit in and try some of. Yeah, I'll try to guide you more on how to approach a standard exam in Java programming or in object-oriented programming. Otherwise, please feel free, ask me. I'm going to share with you this recording onto our online learning platform. Sorry that this recording is very dramatic. I was trying to catch up with time to make sure I deliver this lecture, but I ended up plugging myself in a noisy environment, which is not kind of my things. So let me know. Class rep, please let me know. I don't want the recording to go long. You'll end up spending time listening to these shenanigans, which are not even relevant to your context of study. I'm going to stop the recording. I'm going to also stop the sharing of the screen so that we can have some discussions if they are there anyway. You might not have what to discuss with me, so I've stopped the recording so that